so in 9.2, we're going to be talking about series. So series indicated sum of the terms of a sequence. So remember, a sequence is a list of numbers or a list of terms, okay? When I throw series onto it, it's actually me adding all of those. So we're actually finding the sum of all those numbers. So notice my sequence here is a list of numbers. When I throw a series, I then add all those numbers and I find the sum. So the series is my sum. So S of n is now, instead of A sub n, is what we're going to use. So S of n represents the sum of the first n terms of the series. So whenever you're cued off seeing the equation with an S, that means we're finding the sum of something. Okay, so the sum of S of n is the first n terms of an arithmetic sequence is given by this. So here is our general formula. We're going to use this one. Okay, so S of n is equal to n divided by 2 times A sub 1 plus A sub n. So A sub n is my last term. I referenced it in our sequence. This is my first term. This is my nth term, or my number of terms. Because if you think about it, if it's A sub, or if it's the 7th term, and you're going from 1 to 7, then there would be 7 terms. Okay, and this is going to be standing for my total sum of my series. Okay, so it says find the sum of the first 100 positive integers. Okay, so when I'm trying to find the sum of the first 100 positive integers, so first off, positive means I can't include 0. So I'm basically going from 1 to 100. Okay, so if I'm going from 1 to 100, that's my first term. This is what I consider to be my last term. Alrighty. So I could literally list out my method. I could list out 1, 2, 3, 4, 5, 6, 7, and then I could add all of them. Okay, or we can go into this sum series. I'm not going to worry about this. We're just going to go into the simplified one here. So S of n is equal to n divided by 2, A sub 1 plus A sub n. So let's figure out what we do now. I know my A sub 1, I already talked about, is 1. I know my last term is 100. I'm going from 1 to 100, so there are 100 terms into this. Okay, so I'm doing S of 100, because my n is equal to 100. That's how many terms? N. So I put my 100 over here too. Okay, I'm doing my A sub 1 plus my A sub n. So what you're doing is you're actually kind of finding the average of them. So you're adding them all up, kind of dividing by it. Okay, so we are going to do, you can type all of this into your calculator. I'm going to put this as 50 to make it a little bit easier. Okay, so I've got 50 times 101 basically. So if I added all of those terms, it would be 5,050. Okay, so it says find the sum of the first 20 even numbers beginning at 2. So if I just listed them so we can see them all. So what we're doing, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Okay, I could physically add them all up, but now we have this sequence or this series equation that we can use. So information I know and information I need. So I need the first term, the last term, and my number of terms. Okay, so my first term is 2, my last term is 20. Okay, I have all even numbers. Okay, so if I'm going from 2 to 20, and they're all evens, that means I don't want the odds. I only really want half of them, so there's going to be a total of 10. So I'm doing S of 10 is equal to, I do my n again, first term plus last term. Because you got to cover from the front to the back. That's why we do first term to last term. We're covering from the front, the start, to the back end. So I'm going to do, basically, this is going to give me 5 here to make it a little bit smaller. Or I can add that too. So 5 times 22. So my sum, if I added all those up, would be 110. Okay, so find the first 3 terms of an arithmetic series in which A sub 1 is 9, A sub n is 105, and S sub n is 741. So this time we're actually finding the first 3 terms of it. Okay, so I need to be able to figure out, I need the distance that I'm moving. So I need this information to figure out, well, what is the distance that I move? Because then I can figure out if this is my first term, which I have, I can then move from there. So what we're actually going to do is we're going to use, we have 2 equations that we've learned. We have our, what we call the explicit formula, so our sequence formula, and now we have our sum formula. So the most information I have looks like I can plug into my sum, okay? I gotta solve for different parts here to get to that distance. So I'm gonna fill in all that information here. So S of n is 741. I don't know how many terms. I know my first term and my last term. So what we're gonna do is just solve for n, because then what I can actually do is make my way to the sequence formula to find the letter D. Okay, so if I'm solving, let's go ahead and do 9 plus 105, 114. I'm going to multiply that 2 over to the other side to get rid of them. So 741 times 2 is going to give me 1482. 114. Divide by 114. So n is going to equal 13. So there are 13 terms. So now let's see what I can get out of my other sequence here. So I know my eighth of n is 105. I know my first term is 9. My n is 13, which means there are 13 terms. And now I can find my distance so that I can find my first 3 terms. Okay, so this is going to get me to 12. I can subtract 9. 105 minus 9 is 96. And divide by 12 to give me 8. All right, so now, what was I trying to get first 3 terms? I got the first one, so 9. My distance I'm traveling is 8. So if I do, we're doing arithmetic, so we add 8 to get 17. Add 8 to get 25. There are my first 3 terms, a sub 1, a sub 2, and a sub 3. Okay, so I want you to pause the video. Again, these are manipulations of the 2 equations. So we're going to do the same thing, but with geometric in the next couple of days. Where you're like, what information do I have? Which equation can I use to find more information? Okay, so pause the video and see if you can try number 10 on your own. All right, so I'm going to clear all this out here. So I have my S of n, so 129 is equal to n divided by 2 times 14 plus 29. My calculator. 14 plus 29. It's 43. You could technically take 43 divided by 2 if you didn't want to multiply this 2 over, and it makes the same thing. I like multiplying them over because then I don't get a weird decimal over here. So this is going to give me n times 43, or 43n. Divide by 43. So n is 6. So now I got my a sub n. Here's my sequence formula. So 29 is equal to 14 plus my n was 6. So that gets me 5. Subtract 14. Divide by 5. So the distance I travel is 3. So my first term is 14. I add 3. I add 3. Okay, the other thing that we have with series is sigma notation. Okay, so a sigma notation is big sigma stands for sum. Alrighty, so I've got 3 plus 6 plus 9 plus that plus 30 can be expressed as this. This is n is equal to 1. Okay, so this is going to represent our first term. The bottom is going to kind of be our first term. Okay, this is going to represent what we plug in for our last term. Okay, and this is our sequence formula. We also call it explicit formula. So this is where we see that it's a sequence. So notice it's linear. Okay, when we get to geometric, it will be a geometric equation. Okay, so that is my sequence formula, my explicit sequence formula. So that's that. That's how we're going to find that sometimes. Okay, so the expression is read, the sum of 3n as n goes from 1 to 10. So that's why when it says 1 to 10, that's why that 1 is going to represent what we plug in for our first term, and our 10 is going to be what we represent as our last term. Okay, the variable in this case, n, is called the index of the summation. So evaluate each sum given the sigma notation. So if I go back to that original, if I'm trying to find the sum, so our general equation, remember, is this. All right, so this n equals 1 is represented in my first term. So I'm going to find my first term by plugging the 1 in. Sometimes it will not be a 1. So whatever numbers down here you plug in to represent your first term, 3 times 1 is 3. Okay, I plug this in to find my last term because I'm going from 1 to 10. So I plug 10 in to get 30. So there's my last term. Okay, the other thing I need is my n. So I'm going from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So that is a total of 10. Now all I have to do is plug it all in. So I've got s of 10 is equal to 10 divided by 2. My first term was 3. My last term was 30. Okay, so s of 10 is equal to 5 times 33. So that sum $165. So if I literally plugged in 1, 2, 3, 4, like each number into that 3n spot. So like if I actually plugged it in, I'd have to do 3 times 1 plus plugging 2n plus plugging 3n plus plugging 4n plus plugging 5n all the way to 10 and then add them all. That's going to get you your total sum for that. Okay. So my next one here, I need to find my last term, I need to find my first term, and I need to find n. So I plug this in to find my last term, or to find my first term. So I'm plugging 5 in. Okay, so that's going to get me 15 minus 4, so 11. Plug this in to find my last term. So 3 times 8 minus 4. So 24 minus 4 is 20. I'm going from 5 to 8. So 5, 6, 7, 8. So this is actually 4 terms. That's why listing it out tends to help sometimes so that you're actually understanding it's not 3 terms because I'm going from 5 to 8 because you actually have to include 5. Okay, so I'm doing s of 4 is equal to my m divided by 2. First term, which is 11, plus the last term. So I'm going to get 62. So if I physically plugged in 5 into the equation and added to physically plugging in 6 to the equation, added it to physically plugging in 7 into the equation, added it, and so on and so forth. Okay, that is what is finding that sum. Okay, so our last one here, pause the video and try this one on your own. Okay, so if I have x is equal to 3, my first term, I have 2 times 3 plus 1, so 6 plus 1, so 7. A sub n, I'm plugging in 10, so 21. My n, I'm going from 3 to 10, so 3, 4, 5, 6, 7, 8, 9, 10, so 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 terms. So s of 8 is equal to 8 divided by 2, 7 plus 21. Is 112. Okay. So anytime that you're doing this, just realize this is your sequence equation. So you can also just write a sequence equation to shove in there. So if I needed to make something based on something we already have, so I'm going to put up 1 in here, so we write it in sigma notation just so we can practice it one time. All right, so for this one here, if I said write it in summation notation, we already had this before on our sequences sheet. So I would write my sigma sign. I have a sub 1, a sub 2, a sub 3, a sub 4. Okay, so I am going from 1 to 4. All right, I'm going to represent that 8 is my first term. Okay, to find the equation, now anytime I plug that 1 in, I actually get to 8. This is when we go to our sequence formula. So I have a sub 1 plus n minus 1 times 8. So my first term is 8. I do know my number of terms, but we're not going to plug it in because I want my general equation that I can find any of the terms from 1 to 4. Okay, I know my distance that I was traveling was 9. And then we're going to simplify this. So I'm going to throw that 9 in the front. This is going to get me 9n minus 9. So 9n minus 1. So that is what I'm going to put here, 9n minus 1. Because then if I plug 1 in, I should get my first term. When I plug 2 in, I should get my second term. So if I plug 1 into this, it would get me 9 times 1 minus 1. So 9 times 1 is 9, minus 1 is 8. That's my first term. Okay, here's my double check on my next one. If I plug in 2, it should get me my second term. So 9 times 2 is 18, minus 1 is 17. Okay, then if I plug in 3, I should get to 26. If I plug in 4, I should get to 35. So that's why we leave it general, and I don't actually plug anything in for this and this. Even though I do have them in this situation, I want the general equation for that summation notation. Okay, so I'm going to give you one to try on your own, and then I'll put the answer up here. So I'm going to clear this one out, and I'm going to put another one up for you. Okay, so you're going to try this one here on your own. So pause the video and try this one on your own, and then I will flip up the answers and just kind of talk about it quickly. All right, so I chose this going from 1. This is representative of my first term. Okay, so I'm going from 1. There are total of 6. 1, 2, 3, 4, 5, 6 terms. So 6 should go in there. Okay, I do my explicit sequence formula over there. So I have my first term, my distance, I just put it in the front of the parentheses. I distributed it and combined my terms, and then went ahead and got my equation. So I can do a double check. If I plug 1 in, 2 times 1 gets me to 2, which is my first term. I can also check my last term. If I plug 6 in, 2 times 6 is going to get me to 12.